Hello everyone. Today we will be learning about centroid and orthocenter, which we find in triangles. So first, for some vocabulary, in centroids we're really going to be looking at medians of triangles. And the median of the triangle is the segment from a vertex to the midpoint of the opposite side. So for example, let's see if I had this triangle. Median, one of the medians would be from this vertex. I would go draw a segment, and then this other endpoint would be the midpoint of this opposite side, making these two parts equal to each other. And so this line right here is called the median. The centroid is the point in the triangle where the three medians intersect. And so we actually have some properties that go with these medians in the centroid. That is where they all intersect. And we have the centroid theorem that tells us this. So the centroid theorem tells us that the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. And so basically that's saying, so if I'm going from this vertex here to A all the way to the midpoint E, my centroid P here is 2/3 of the way. So this AP makes up 2/3 of the segment, and PE would be the remaining 1/3. And so another way that we can think about it is that the medians of triangle ABC meet at point P, and AP is equal to 2/3 AE. And so we see that here. My segment here, AP, is equal to 2/3 of the entire segment. BP is going to be 2/3 of BF, and CP is going to be 2/3 of CD. And so there's other ways that we can think about this as well. So if AP is 2/3 of my entire segment AE, then that would also mean that PE is equal to 1/3 of AE. And so on for the rest of these. So PF would equal to 1/3 of BF. And PD would equal to 1/3 of CD. So again, the one that's 2/3 of the way is the one that is coming from the vertex. That is the one that ends up being 2/3 of the entire median. And then one other relationship that we get from this is that the one that's 2/3 of the way, so for instance, AP is going to be twice as long as PE. And so I can also say that AP is equal to 2 PE. So for instance, if PE here was 5, that would mean that AP is 10. It's going to be twice the distance of that. And I can do that for the rest of these. So BP is equal to 2 PF, and CP is equal to 2 PD. So we have a lot of different relationships that come from this. In the next video, we'll look at some examples applying these.